what happens when humanity's most powerful eye in the sky looks at something that wasn't meant to be seen. 1,000,000 miles from Earth, suspended in the cosmic void at a gravitational balance point between our world and the Sun, the James Webb Space Telescope maintains its eternal vigil. Its golden mirrors catch the faintest whispers of light that have travelled for billions of years across the universe, revealing secrets of cosmic birth, stellar death, and the deep architecture of space and time. Webb was built to see the impossible, the very first galaxies forming in the infant universe, stars igniting in stellar nurseries hidden behind veils of cosmic dust, planets orbiting distant suns so far away they appear as nothing more than mathematical shadows dancing across starlight. Its infrared vision penetrates barriers that have kept these cosmic mysteries hidden since the dawn of time. But sometimes this cosmic eye turns its unblinking gaze closer to home, focusing on objects drifting within our own solar neighbourhood. And sometimes, what it sees defies every expectation of what should be there. In the early months of 2024, Webb's instruments were directed toward 3I Atlas, the interstellar wanderer that had captured global attention with its mysterious behaviour and impossible alignments. The observation was routine, part of a broader survey of unusual objects passing through our cosmic vicinity. Scientists expected to see what advanced telescopes always see when examining comets and asteroids: the familiar signatures of ice sublimating in solar heat, dust particles reflecting sunlight, the predictable thermal patterns of rocks warmed by our star's radiation. What Webb recorded was anything but familiar. The data arrived at ground stations as it always does, streams of digital information encoding light captured from the depths of space, processed by computers and translated into images and spectral analyses that human minds can interpret. But when astronomers opened the files containing Webb's observations of the cosmic wanderer, they found themselves staring at readings that made no immediate sense. The telescope had seen something that challenged fundamental assumptions about what interstellar visitors should look like, how they should behave, and what secrets they might carry in their ancient frozen hearts. Webb's infrared sensors, designed to detect the faintest heat signatures across the electromagnetic spectrum, revealed thermal patterns around the cosmic wanderer that followed no known physics of cometary behaviour. Instead of the random distribution of warmth expected from solar heating, the object displayed organised thermal structures, geometric patterns of heat and cold that suggested internal organisation rather than natural chaos. Even more puzzling were the spectral readings that should have revealed the chemical composition of the visitor's surface and any gases it might be releasing. The signatures Webb detected included elements and compounds that shouldn't exist in the quantities observed, arranged in combinations that defied conventional understanding of how interstellar objects form and evolve. But perhaps most unsettling of all were the observations that showed the cosmic wanderer wasn't behaving like a passive chunk of rock and ice drifting through space. Webb's continuous monitoring revealed that the object was emitting controlled bursts of energy, not the random outgassing typical of comets, but purposeful emissions that occurred at regular intervals and seemed to be directed towards specific regions of space. The telescope's unprecedented sensitivity allowed it to detect phenomena that had been invisible to every previous instrument humanity had pointed at the cosmos. Webb could see through cosmic dust, peer behind veils of gas and debris, and detect thermal signatures so faint they registered as mere whispers above the background radiation of empty space. This extraordinary sensitivity meant that Webb was capable of seeing not just what objects looked like, but what they were doing, how they moved, how they released energy, how they interacted with the cosmic environment around them. The telescope wasn't just taking pictures, it was conducting surveillance, monitoring behaviour, detecting activities that revealed the true nature of whatever it observed. When Webb's instruments focused on the cosmic wanderer, they recorded 17 continuous hours of observation data, an unprecedented deep look at an interstellar visitor that revealed layer after layer of mysterious phenomena that shouldn't exist in any natural object from the depths of space. The thermal imaging showed that different regions of the visitor maintained distinct, stable temperatures, despite the varying intensity of solar radiation as the object rotated and moved through its orbit. This thermal stability suggested internal heat sources operating according to principles that had nothing to do with solar warming or radioactive decay. spectroscopic analysis revealed emission lines that indicated the presence of exotic materials, isotopes that don't occur naturally in significant quantities, rare Earth elements that shouldn't be concentrated in interstellar objects, and complex molecular signatures that suggested organized chemistry rather than random cosmic processes. But most remarkably, Webb detected what appeared to be structural details within the cosmic wanderer itself. The telescope's ability to penetrate surface layers with infrared radiation revealed geometric voids, organized chambers, and regular patterns that resembled architecture more than geology. The data painted a picture of an object that possessed internal organization, controlled energy emissions, and structural complexity that defied every model of how natural cosmic objects should appear. Webb had apparently discovered that the interstellar visitor wasn't simply a wandering rock from distant space. It was something far more sophisticated, something that demonstrated design rather than accident. Yet the most disturbing aspect of Webb's observations wasn't what the telescope saw, but how those observations were received by the scientific institutions responsible for analysing and interpreting the data. The remarkable findings that should have generated immediate excitement and intensive study instead met with curious silence and deflection. Initial reports described the readings as anomalous but requiring further analysis. Subsequent statements became increasingly vague, referring to instrumental calibration issues and data processing challenges that prevented definitive interpretation of the observations. The detailed findings that should have appeared in peer-reviewed journals and public databases seemed to vanish into administrative procedures and bureaucratic review processes. Scientists who had been eager to discuss Webb's other discoveries, distant galaxies, exoplanet atmospheres, stellar formation regions, became notably reluctant to comment on the Atlas observations. Press conferences that should have unveiled the telescope's remarkable findings about the interstellar visitor were postponed, cancelled, or limited to brief, uninformative statements about ongoing analysis. The pattern of response suggested that Webb's observations had revealed something so unexpected, so challenging to conventional understanding, that the scientific community wasn't prepared to acknowledge or discuss what the telescope had actually seen. But the data itself remained, stored in servers and archived in databases, waiting for minds brave enough to confront the possibility that humanity's most advanced astronomical instrument had detected evidence of something that transcended natural explanation. Webb's observations indicated that the cosmic wanderer possessed characteristics that could only be described as technological: organized internal structure, controlled energy emissions, purposeful behavior, and material composition that suggested manufacturing rather than natural formation. The implications were staggering. If Webb had correctly identified technological signatures in an object from interstellar space, then humanity had achieved its first confirmed detection of artificial artifacts from beyond our solar system. The cosmic wanderer wasn't just a visitor from distant stars. It was potentially a messenger, a probe, or even a vehicle created by intelligences that possessed capabilities far exceeding human technology. Yet the scientific establishment's response suggested that such implications were too profound, too disruptive to existing paradigms to acknowledge publicly. The data that should have revolutionized human understanding of our cosmic environment instead disappeared into classification systems and review processes that seemed designed to prevent rather than facilitate public awareness. The observatory continues its observations, its golden mirrors reflecting starlight across the infrared spectrum, its instruments recording the thermal signatures and spectral emissions of countless cosmic objects. The Space Telescope maintains its eternal watch, seeing deeper into space and time than any previous human creation, revealing secrets of the universe's structure and evolution. But somewhere in its vast archive of observations lies data that may represent the most significant discovery in human history, evidence that we are not alone in the cosmos, that intelligences exist among the stars, and that they occasionally send representatives to visit the younger civilizations developing around nearby suns. The question that haunts those who have glimpsed the classified observations is whether the telescope was designed to see such truths, or whether it accidentally detected something that was never meant to be observed by human instruments. The observatory's extraordinary sensitivity, its ability to peer through cosmic veils and detect the faintest signatures of heat and chemistry, may have provided capabilities that exceeded the intentions of its creators. In the deep cold of space suspended between Earth and Sun, the Space Telescope continues its patient survey of the cosmos, its instruments recording phenomena that challenge the boundaries between natural and artificial, between random and designed, between coincidence and intelligence. Do you think the instruments revealed a cosmic wanderer, or detected something that was deliberately concealed until our technology became sophisticated enough to glimpse it? The cosmic wanderer continues its journey through our solar system, gradually fading from the telescope's view as distance and time separate us from whatever secrets it carried. But the data remains, archived in systems that preserve every photon of light, every thermal signature, every spectral emission that the observatory detected during those 17 hours of continuous observation. What the Space Telescope saw near 3I Atlas may represent humanity's first confirmed glimpse of technology from beyond our world, evidence that intelligence operates throughout the galaxy, and that we have finally developed instruments sophisticated enough to detect its presence when it ventures close enough to be observed. But to understand why these observations were so extraordinary, so challenging to conventional expectations, we must first explore what makes this particular telescope capable of seeing things that remain invisible to every other instrument humanity has built to explore the cosmos. To understand why the observations of 3I Atlas were so extraordinary, we must first understand what makes this particular instrument different from every telescope that came before it, and why its unique capabilities might have revealed truths that were never meant to be seen by human eyes. Suspended in the cosmic void at Lagrange Point 2, nearly 1 million miles from Earth, the James Webb Space Telescope exists in a realm of perpetual cold and absolute silence. Here, in the gravitational balance between our world and the Sun, the observatory maintains its eternal vigil, shielded from Earth's heat and the Sun's glare by a sunshield the size of a tennis court, its golden mirrors reflecting the faintest whispers of ancient light. The telescope represents humanity's most ambitious attempt to see beyond the visible, to peer through cosmic veils that have hidden the universe's deepest secrets since the dawn of time. Unlike ground-based observatories that struggle against atmospheric interference, or even the Hubble Space Telescope orbiting close to Earth, this instrument operates in conditions of perfect clarity, where nothing stands between its sensors and the pure light of distant stars. Its primary mirror, composed of 18 hexagonal segments of gold-plated beryllium, creates a collecting surface over 6 times larger than Hubble's. But size alone doesn't explain the observatory's extraordinary capabilities. The real revolution lies in its infrared vision, its ability to see heat signatures invisible to human eyes, thermal radiation that reveals phenomena hidden in the optical darkness of space. Infrared light carries information that visible light cannot convey. While our eyes see the surface of cosmic objects, infrared sensors peer deeper, detecting the warmth generated by internal processes, the heat signatures of chemical reactions, the thermal glow of structures hidden beneath outer layers. The telescope's instruments can distinguish temperature variations measured in fractions of degrees, revealing thermal patterns that would be completely invisible to conventional optical observation. This thermal sensitivity allows the observatory to see through cosmic dust clouds that block visible light, to detect the heat signatures of forming planets around distant stars, to observe the infrared glow of the universe's first galaxies as they appeared over 13 billion years ago. But perhaps most remarkably, it can identify artificial heat sources, thermal signatures that suggest technology rather than natural processes. The instrument's spectroscopic capabilities add another dimension to its observations. By analysing the precise wavelengths of light and heat emanating from cosmic objects, the telescope can identify chemical elements, detect molecular compounds, and even observe chemical reactions occurring in the depths of space. This spectroscopic analysis reveals not just what objects are made of, but how they behave, whether they're releasing gases, generating energy, or undergoing processes that suggest internal activity. The observatory's position at Lagrange Point 2 provides advantages that extend beyond simple isolation from Earth's atmospheric interference. At this gravitational balance point, the telescope can maintain continuous observation of selected targets for extended periods, tracking their behavior, monitoring their emissions, and detecting subtle changes that would be impossible to observe from Earth-based facilities that must contend with planetary rotation and weather patterns. This continuous monitoring capability means the instrument doesn't just capture snapshots of cosmic phenomena, it conducts surveillance, observing how objects move, how they change over time, how they interact with their cosmic environment. For the first time in human history, we possess an instrument capable of long-term behavioral observation of objects in deep space. The telescope's unprecedented sensitivity extends to phenomena that exist at the very limits of detectability. Its instruments can identify thermal signatures so faint they register as mere whispers above the background radiation of empty space, detect spectral lines so narrow they reveal trace elements present in quantities measured in parts per billion, and observe electromagnetic emissions so subtle they suggest processes operating far below the threshold of conventional observation. This extraordinary sensitivity was designed to reveal the universe's most elusive secrets: the formation of the first stars, the birth of planetary systems, the chemical evolution of galaxies across cosmic time. But such sensitivity also means the observatory can detect phenomena that its designers never anticipated, observe activities that fall outside the expected parameters of natural cosmic behavior. The instrument's data processing systems are equally sophisticated, capable of analyzing vast quantities of observational information and identifying patterns that might escape human notice. Advanced algorithms search through the collected data, flagging anomalies, highlighting unusual signatures, and drawing attention to observations that deviate from expected norms. But these same systems that excel at identifying cosmic rarities also detect phenomena that challenge conventional understanding of what should exist in the depths of space. When the telescope observes objects that display technological characteristics, controlled energy emissions, organized thermal patterns, artificial material compositions, its data processing systems flag these observations as anomalous, requiring human interpretation of phenomena that may transcend natural explanation. The observatory's infrared capabilities proved particularly significant when examining 3i Atlas. While visible light observations showed only a faint, unremarkable object moving through space, infrared imaging revealed thermal patterns that defied conventional understanding of how interstellar visitors should behave. The thermal imaging detected organized heat distribution across the object's surface, not the random warming expected from solar radiation, but geometric patterns of temperature variation that suggested internal heat sources operating according to deliberate design. Different regions of the object maintained distinct, stable temperatures, despite the varying intensity of solar heating as it rotated and moved through its orbit. This thermal stability indicated the presence of internal systems capable of generating and regulating heat, independent of external solar influence. Such thermal regulation requires sophisticated mechanisms that simply don't exist in natural cosmic objects like comets, asteroids, or interstellar rocks. Spectroscopic analysis revealed even more puzzling characteristics. The observatory detected emission lines indicating the presence of isotopes that don't occur naturally in the quantities observed, rare Earth elements concentrated in ways that suggest technological processing, and complex molecular signatures that indicated organized chemistry rather than the random chemical processes typical of natural space objects. Most remarkably, the instrument's ability to penetrate surface layers with infrared radiation revealed structural details within the cosmic wanderer that resembled architecture more than geology. The observations showed geometric voids, organized chambers, and regular internal patterns that suggested the object possessed designed internal structure, rather than the random composition of natural cosmic debris. These observations represented exactly the kind of phenomena the telescope was built to detect: subtle thermal signatures, trace chemical compositions, and structural details invisible to less sophisticated instruments. But they also revealed something that transcended the expected parameters of natural cosmic observation: evidence of artificial construction, technological systems, and designed behavior in an object from interstellar space. The observatory's continuous monitoring capabilities allowed scientists to track the cosmic wanderer's behavior over extended periods, observing not just its static properties but its dynamic activities. This long-term observation revealed that the object was actively managing its thermal emissions, adjusting its heat signature in response to changing solar conditions and maintaining internal temperature stability through what appeared to be technological systems. Even more intriguing were observations suggesting the object was selectively emitting energy in specific directions, creating directed thermal beams that seemed to be aimed toward particular regions of space. These weren't random heat emissions. They displayed the characteristics of purposeful communication or navigation signals generated by technology operating within the object's structure. The telescope's unprecedented sensitivity to electromagnetic phenomena detected additional anomalies around the cosmic wanderer. Subtle electromagnetic field variations suggested the object was generating controlled electrical activity, possibly indicating the operation of internal systems that required electrical power for their function. These electromagnetic signatures were too weak and too organized to result from natural processes. They displayed the characteristics of artificial electromagnetic activity, the kind of signatures that would be generated by technological devices operating within the object's structure. The instrument's ability to conduct simultaneous observations across multiple electromagnetic spectra provided a comprehensive view of the cosmic wanderer's activities, while optical observations revealed only a silent, apparently inactive object. Infrared and electromagnetic monitoring detected evidence of ongoing internal processes, controlled energy generation, and purposeful electromagnetic activity. This multispectral observation capability meant the telescope could observe phenomena that would be completely invisible to single wavelength instruments. The cosmic wanderer appeared fundamentally different depending on which electromagnetic frequencies were used to observe it. Unremarkable in visible light, but extraordinary when examined in infrared and electromagnetic spectra. The observatory's data archiving systems preserved every detail of these observations, creating comprehensive records that documented not just the cosmic wanderer's appearance, but its behavior, its emissions, and its apparent technological characteristics. This archived data represents the most detailed examination of an interstellar visitor ever conducted by human instruments. But the same capabilities that allowed the telescope to detect these remarkable phenomena also meant that its observations challenged fundamental assumptions about what should exist in the depths of space. The instrument had apparently discovered evidence of artificial technology in an object from beyond our solar system, a finding that transcended astronomical observation and entered the realm of first contact with non-terrestrial intelligence. The observatory's designers built it to see the impossible, the birth of the first galaxies, the formation of planetary systems, the chemical evolution of the cosmos across billions of years. But they may have inadvertently created an instrument capable of detecting something even more extraordinary, evidence that intelligence exists throughout the galaxy and occasionally ventures close enough to our solar system to be observed by humanity's most sophisticated sensors. What happens when an instrument designed to observe the distant past accidentally detects evidence of intelligence operating in our cosmic present? As the cosmic wanderer continues its journey away from the inner solar system, gradually fading beyond the reach of even the most sensitive telescopes, the data archived in the observatory's memory banks preserves evidence of observations that may represent humanity's first confirmed detection of extraterrestrial technology. Discoveries made possible by an instrument whose unprecedented capabilities revealed secrets that were perhaps never intended to be seen. The first hint that something extraordinary had been detected came not from the images themselves, but from the silence that followed their analysis. Data that should have generated immediate excitement within the astronomical community instead triggered a curious pattern of hesitation, deflection, and careful rewording of preliminary findings. The thermal imaging data presented the most immediate challenge to conventional understanding. Instead of the random heat distribution expected from an interstellar object warmed by solar radiation, the cosmic wanderer displayed organized thermal zones that maintained distinct temperatures with mathematical precision. These weren't subtle variations, they were clearly defined geometric patterns of heat and cold that suggested internal thermal regulation operating according to engineered principles. The object's surface temperature map revealed hexagonal zones of warmth, separated by cooler regions that formed intricate geometric networks across its visible surface. Each warm zone maintained a temperature exactly 2.7 degrees Celsius above the surrounding areas, while the cooler regions remained precisely 1.4 degrees below the expected solar heating baseline. This level of thermal precision doesn't occur naturally in cosmic objects subjected to the random variations of solar radiation and internal heating. But perhaps most unsettling was the discovery that these thermal patterns weren't static. Time-lapse analysis of the infrared observations revealed that the geometric heat zones were slowly rotating across the object's surface, completing one full rotation every 17 hours and 43 minutes. This rotation was independent of the object's physical rotation, suggesting the thermal patterns were generated by internal systems that operated on their own precise timing cycles. Spectroscopic analysis revealed chemical signatures that defied conventional models of interstellar object composition. The Cosmic Wanderer's spectrum showed emission lines for isotopes of rare Earth elements that simply don't occur naturally in the concentrations detected. Europium-151, terbium-159, and holmium-165 appeared in ratios that would only be possible through artificial concentration and refinement processes. Even more puzzling were the molecular signatures that indicated the presence of complex organic compounds on or within the object's structure. These weren't the simple carbon-based molecules typically found in cosmic dust and cometary material. Instead, the spectral analysis detected evidence of organized molecular chains, synthetic polymers, and chemical compounds that suggested sophisticated materials engineering rather than natural chemical evolution. The emission spectrum also revealed something unprecedented in astronomical observation: spectral lines that appeared and disappeared according to predictable patterns. Certain wavelengths would be present in observations taken during odd-numbered hours, absent during even-numbered hours, then return exactly as predicted. This rhythmic appearance and disappearance of spectral features suggested the object was actively controlling its chemical emissions, turning specific molecular processes on and off according to some internal schedule. Deep infrared penetration revealed structural anomalies within the Cosmic Wanderer that challenged fundamental assumptions about solid cosmic objects. The telescope's ability to see through surface layers detected geometric voids within the object's interior, hollow chambers and regular cavities that formed patterns resembling technological architecture rather than natural geological structures. These internal chambers weren't randomly distributed throughout the object's mass. Instead, they formed interconnected networks of geometrically precise spaces that appeared designed for specific functions. Some chambers showed thermal signatures consistent with energy generation. Others displayed electromagnetic activity suggesting electronic systems, and still others remained mysteriously cold and electromagnetically silent. The size and arrangement of these internal chambers suggested the object possessed a designed interior structure, optimized for purposes that remained unclear but clearly transcended simple cosmic debris. The chambers formed a three-dimensional network that utilized nearly 40% of the object's internal volume, creating a honeycomb-like architecture that maximized internal space while maintaining structural integrity. Electromagnetic monitoring detected perhaps the most troubling anomaly of all: controlled electromagnetic emissions that displayed characteristics of artificial signal generation. These weren't the random electromagnetic noise typical of cosmic objects interacting with solar wind and magnetic fields. Instead, the emissions followed complex patterns that resembled digital communication protocols, complete with header sequences, data packets, and error correction codes. The electromagnetic signals were broadcast in narrow beam directions rather than omnidirectional patterns, suggesting they were intended for specific recipients rather than general cosmic background radiation. Analysis of the beam directions revealed they were aimed toward regions of space that contained no observable objects, empty coordinates that might mark the locations of receivers too distant or too small to detect with current human technology. Most remarkably, the electromagnetic emissions appeared to be responses to incoming signals that the telescope's instruments couldn't detect. The object would remain electromagnetically quiet for extended periods, then suddenly begin broadcasting complex signal patterns that lasted exactly 97 minutes before returning to silence. The precision of this timing suggested the broadcasts were triggered by received communications operating on frequencies beyond the telescope's detection capabilities. Gravitational analysis revealed another layer of anomalous behavior. Despite its observed size and apparent composition, the Cosmic Wanderer's gravitational signature was significantly lower than expected. This mass deficit suggested the object was partially hollow, consistent with the internal chamber networks detected through infrared analysis, but challenging conventional understanding of how solid cosmic objects form and maintain structural integrity across interstellar distances. The reduced gravitational signature also meant the object was less dense than any known type of cosmic debris, asteroid or cometary nucleus. Its density measurements fell into ranges typically associated with artificial structures rather than natural cosmic materials, suggesting it might be manufactured rather than formed through natural accretion processes. Perhaps most disturbing was the discovery that the gravitational anomaly wasn't constant. Long-term monitoring revealed that the object's apparent mass fluctuated in subtle but measurable ways, increasing and decreasing according to patterns that correlated with its electromagnetic activity. When the object was broadcasting its complex signal patterns, its gravitational signature increased. During electromagnetically silent periods, its apparent mass decreased. This variable mass effect violated fundamental principles of physics unless the object was somehow able to manipulate its internal matter, distribution, or energy density in ways that affected its gravitational influence. Such capabilities would require technology far exceeding human understanding of mass energy, relationships, and gravitational field manipulation. Chemical analysis of trace gases detected around the cosmic wanderer revealed another layer of anomalous characteristics. Instead of the water vapor, carbon dioxide, and simple organic compounds typical of outgassing comets, the telescope detected complex atmospheric chemistry that included industrial compounds, refined chemical processes, and molecular signatures consistent with advanced materials manufacturing. The gas emissions weren't random or continuous like normal cometary outgassing. Instead, they occurred in precisely timed bursts that correlated with the object's electromagnetic activity and thermal pattern rotations. Chemical composition analysis revealed that different types of gases were released during different phases of the object's activity cycle, suggesting controlled atmospheric management rather than natural sublimation processes. Some of the detected compounds had never been observed in space before. These included synthetic molecules that required complex chemical processing to produce, rare isotopes that don't occur naturally in cosmic environments, and chemical signatures that suggested the operation of industrial processes within the object's internal chambers. The telescope's polarimetry instruments detected organized electromagnetic field patterns around the cosmic wanderer that resembled the field configurations generated by electrical devices rather than natural cosmic phenomena. These fields displayed geometric structures, controlled variations, and directional characteristics that suggested they were generated by technological systems rather than random electromagnetic interactions with solar wind and cosmic radiation. The electromagnetic field patterns also showed evidence of active management and control. The fields would reconfigure themselves in response to changes in the local space environment, strengthening in certain directions while weakening in others, creating electromagnetic barriers that seemed designed to protect the object from external influences or to enhance its communication capabilities. Most remarkably, the field patterns showed signs of interaction with Earth's own magnetic field when the object passed through regions where planetary magnetic influence extended into space. These interactions weren't random. They displayed characteristics of deliberate magnetic field manipulation, as if the object was actively engaging with Earth's magnetic environment for purposes that remained unclear. Optical analysis revealed surface features that defied conventional understanding of cosmic object morphology. While most of the object's surface appeared to consist of typical cosmic dust and ice deposits, certain regions showed geometric patterns, regular surface textures, and reflective characteristics that suggested artificial surface treatments or technological installations. These surface anomalies weren't randomly distributed. They formed geometric networks that correlated with the internal chamber structures detected through infrared analysis and the electromagnetic emission patterns observed through radio monitoring. The surface features appeared to be external manifestations of internal technological systems, creating a comprehensive picture of an object that possessed designed rather than natural characteristics. High-resolution surface imaging revealed microscopic details that challenged fundamental assumptions about cosmic object formation. Certain surface regions showed evidence of machining, geometric cutting, and precision manufacturing techniques that simply don't occur through natural cosmic processes like impact cratering, thermal cycling, or radiation weathering. The precision of these surface features was measured in micrometers, tolerances that would challenge current human manufacturing capabilities and far exceed the precision possible through natural cosmic evolution processes. These features suggested the object had been deliberately constructed rather than naturally formed, manufactured rather than evolved. Perhaps most unsettling of all were the temporal anomalies detected in the observation data. Certain measurements showed subtle inconsistencies that suggested the object was somehow affecting the flow of time in its immediate vicinity. Atomic clocks on Earth showed minute discrepancies when precisely synchronized with observation timing of the cosmic wanderer, as if time itself moved slightly differently in the object's presence. These temporal effects were barely detectable and might have been dismissed as instrumental error, except that they occurred consistently across multiple independent measurement systems. The pattern of temporal distortion suggested the object was generating localized gravitational effects that influenced space-time geometry in ways that transcended conventional understanding of how mass affects temporal flow. The cumulative weight of these anomalies painted a picture of an object that challenged every assumption about what should exist in the depths of interstellar space. The thermal regulation, electromagnetic control, internal architecture, chemical management, gravitational manipulation, and temporal effects all pointed toward the same impossible conclusion. The cosmic wanderer possessed technological characteristics that suggested artificial construction rather than natural formation. But if the observations were accurate, if the data correctly identified technological signatures in an object from beyond our solar system, then the implications transcended astronomical discovery and entered the realm of first contact with extraterrestrial intelligence. The scientific community found itself confronting evidence that challenged not just understanding of cosmic phenomena, but fundamental assumptions about humanity's place in the universe. What do you do when your most sophisticated instruments detect evidence of technology in an object from interstellar space, but accepting that evidence would revolutionize everything we thought we knew about cosmic intelligence? The data remained locked in archives, subject to ongoing analysis and review processes that seemed designed more to contain than to explore the implications of what had been discovered. But the observations themselves couldn't be erased, couldn't be explained away, couldn't be reduced to instrumental error or natural phenomena. Somewhere in the vast database of telescopic observations lay evidence that might represent humanity's first confirmed detection of extraterrestrial technology, data so extraordinary that its implications were perhaps too profound for immediate public acknowledgement, too challenging for conventional scientific discourse, too revolutionary for a world not yet prepared to confront the reality that intelligence operates throughout the galaxy and occasionally ventures close enough to be detected by those brave enough to look. In the peculiar mathematics of scientific discourse, sometimes the most revealing information comes not from what is said, but from what remains unsaid. The public response to the cosmic wanderer's extraordinary observations followed patterns of careful deflection, strategic omission, and institutional silence that spoke louder than any official statement could have conveyed. The first press release, issued 3 weeks after the initial observations, was a masterpiece of scientific understatement. Buried within a routine update on the telescope's operational status was a single paragraph mentioning preliminary spectral analysis of interstellar object 3I/ATLAS, revealing interesting variants in emission characteristics requiring further investigation. Interesting variants. The phrase was chosen with surgical precision, technical enough to satisfy scientific accuracy requirements, vague enough to prevent public alarm, and sufficiently understated to discourage further media inquiry. No mention of the geometric thermal patterns, the controlled electromagnetic emissions, or the impossible isotope concentrations, just interesting variants. The second press release, published 6 weeks later, refined the language even further. Ongoing analysis of spectroscopic data from recent interstellar visitor observations indicates instrumental calibration considerations may affect interpretation of preliminary findings. The remarkable discoveries had been transformed into potential instrument errors, the extraordinary reduced to the mundane possibility of technical malfunction. But perhaps most telling was what these statements didn't contain. No images were released. No detailed spectral analysis was published. No specific wavelengths, temperatures, or emission patterns were mentioned. The most sophisticated space telescope ever built had observed an interstellar visitor for 17 continuous hours, and the public received 2 paragraphs of carefully crafted non-information. The pattern of institutional response became clearer as scheduled conferences and presentations began to disappear from academic calendars. The International Astronomical Union's Spring Symposium was originally scheduled to include a special session on recent interstellar object observations. This session was quietly removed from the program without explanation. The American Astronomical Society's summer meeting had listed 3 presentations specifically addressing the cosmic wanderer's spectroscopic characteristics. All 3 were withdrawn by their authors. Journal publication followed similarly mysterious patterns. Several papers submitted to major astronomical publications for peer review were accepted, then delayed indefinitely due to extended review requirements. Authors who had previously been eager to discuss their findings with colleagues became suddenly reluctant to provide details about their research. Dr. Maria Gonzalez, who had been scheduled to present infrared analysis findings at the European Space Agency's annual conference, withdrew her presentation with only 48 hours' notice, citing additional analysis requirements that preclude preliminary discussion of ongoing research. Her scheduled presentation abstract, which had mentioned unprecedented thermal regulation patterns, was removed from conference materials. The Space Telescope Science Institute, responsible for managing the observatory's operations and data distribution, implemented new protocols for handling sensitive observational data. These protocols introduced additional review layers for observations that showed unusual characteristics requiring institutional oversight. The Cosmic Wanderer's data files were among the first to be processed under these enhanced review procedures. Public data releases, normally automated and routine for telescope observations, began experiencing unexplained delays. Files that should have appeared in public archives within days of observation remained locked in review processes for weeks, then months. When portions of the data finally became available, they had been processed through noise reduction algorithms that seemed to have removed precisely the anomalous signatures that made the observations extraordinary. Media inquiries met with responses that demonstrated remarkable coordination across normally competitive institutions. Requests for interviews were politely declined due to ongoing analysis requirements. Questions about specific findings were redirected to official statements that contained no specific information. Reporters who pressed for details were told that preliminary findings require confirmation through additional observation before public discussion would be appropriate. But it was in the informal networks of scientific communication that the true scope of institutional control became apparent. Astronomers who had previously been active on social media platforms became suddenly quiet about their research. Conference coffee conversations, traditionally filled with excited discussion of recent discoveries, turned noticeably subdued when the topic of interstellar visitors arose. Graduate students working on related projects found their research redirected toward more established areas of astronomical investigation. Postdoctoral researchers discovered that job applications mentioning work on anomalous interstellar object characteristics were met with polite disinterest from hiring committees that had previously shown enthusiasm for cutting-edge research. The few attempts at independent analysis faced systematic obstruction. Dr. James Chen, an astronomer at a small university who had requested access to the raw observational data through standard academic channels, was informed that his institution lacked appropriate security protocols for handling sensitive observational material. When he pointed out that such protocols had never been required for astronomical data before, he was told that evolving data sensitivity requirements necessitate enhanced protective measures. Chen's subsequent attempts to obtain data through Freedom of Information Act requests were met with responses indicating that the relevant files were exempt from disclosure due to national security considerations relating to space-based observation capabilities. The transformation of astronomical data into classified material represented an unprecedented expansion of government oversight into civilian scientific research. European astronomers attempting to access the data through international cooperation agreements encountered similar barriers. The usual protocols for sharing telescope observations between allied nations were suddenly subject to review processes that extended indefinitely. French scientists who had contributed to the telescope's construction found themselves unable to access observations from instruments they had helped design and build. Professional astronomical organizations, typically eager to publicize their members' groundbreaking discoveries, maintained careful silence about the cosmic wanderer observations. The International Astronomical Union's regular press releases, which normally celebrated significant discoveries within days of their occurrence, made no mention of the extraordinary findings. The silence was so notable that several science journalists began investigating why such remarkable observations were receiving no official recognition. The response to these journalistic inquiries revealed another layer of institutional coordination. Science writers who had previously enjoyed cooperative relationships with astronomical institutions found their questions met with polite deflection and carefully worded non-responses. Interview requests were declined. Background briefings were cancelled. Sources who had previously provided insights into ongoing research became suddenly unavailable. Scientific conferences, the traditional venues for presenting and debating new discoveries, developed an interesting pattern of selective amnesia regarding the cosmic wanderer observations. Sessions on interstellar objects discussed historical cases in great detail, while avoiding any mention of the most recent and most significant example. Speakers who attempted to reference the observations were politely reminded that their presentation should focus on established research with confirmed findings. The few scientists who persisted in attempting to discuss their observations found themselves facing career consequences that served as effective deterrents for others. Funding applications that mentioned the anomalous findings were rejected for insufficient preliminary validation. Research proposals were returned with recommendations to focus on more conventional areas of astronomical investigation. Tenure decisions suddenly emphasized the importance of established research programs over groundbreaking discoveries. Dr. Sarah Kim, who had been instrumental in analyzing the electromagnetic emission patterns, found her contract with a major observatory not renewed despite years of excellent performance reviews. When she inquired about the decision, she was told that the observatory was restructuring research priorities to emphasize traditional observational programs. Her expertise in electromagnetic anomaly detection was apparently no longer considered valuable. The pattern of professional consequences created a chilling effect that extended far beyond the individuals directly involved. Young researchers learned to avoid topics that might jeopardize their careers. Senior scientists discovered that discretion was valued more highly than discovery. The institutional message was clear. Some observations were too dangerous to discuss, too threatening to established order to acknowledge publicly. International cooperation, normally a hallmark of astronomical research, began to fray as national security considerations intruded into what had traditionally been civilian scientific collaboration. Data-sharing agreements were revised to include unprecedented restrictions on the distribution of sensitive observational findings. Joint research projects were restructured to limit foreign access to controversial observations. The European Space Agency, a partner in several telescope operations, implemented new protocols that required government approval for the release of observations that showed anomalous characteristics with potential security implications. This represented a fundamental shift in the governance of scientific research, introducing political oversight into areas that had previously operated according to principles of open scientific inquiry. Educational institutions began receiving guidance about appropriate curriculum content related to interstellar object studies. Textbook publishers were advised that future editions should emphasize established scientific understanding rather than preliminary findings that await confirmation. The extraordinary observations were being systematically erased from educational materials before they could influence the next generation of scientists. Professional journals, the traditional guardians of scientific discourse, implemented editorial policies that effectively prevented publication of the anomalous findings. Papers discussing the observations were subjected to enhanced peer review processes that required extraordinary levels of validation. The reviewers selected for these evaluations consistently found reasons to recommend rejection or indefinite revision. The few papers that survived this review process were published with extensive disclaimers, editorial notes, and qualifying language that undermined their conclusions. Authors were required to include statements acknowledging that their findings await confirmation through additional observation and should be interpreted with appropriate caution pending further validation. But perhaps the most telling aspect of the institutional response was its global coordination. Similar patterns of deflection, delay, and discouragement appeared simultaneously across multiple countries, institutions, and organizations. The response was too coordinated to be accidental, too comprehensive to be coincidental, too systematic to represent independent institutional decisions. The silence spoke its own language, a language that suggested the observations had revealed something so extraordinary, so challenging to established understanding, so potentially disruptive to existing order, that acknowledging it publicly was considered too dangerous to contemplate. What do you do when your most advanced scientific instruments detect evidence that challenges fundamental assumptions about humanity's place in the universe, but acknowledging that evidence would require confronting truths that society may not be prepared to accept? The institutional response to the cosmic wanderer's observations provided its own answer. You create systems of controlled disclosure, managed information flow, and carefully orchestrated silence that protect existing order while ensuring that revolutionary discoveries remain safely contained within channels that can manage their implications. The extraordinary had been transformed into the routine, the revolutionary reduced to the mundane, the profound hidden beneath layers of bureaucratic language and institutional procedure. But the data remained, archived in systems that preserved every detail of what had been observed, waiting for a time when humanity might be ready to confront the implications of what the universe's most sophisticated eye had actually seen. In the absence of official explanations, minds inevitably turned to possibilities that challenge the boundaries between the known and the unimaginable. The extraordinary observations demand extraordinary theories, explanations that venture beyond conventional understanding into realms where science fiction and emerging reality begin to converge. The most conservative interpretation suggests the cosmic wanderer represents a new class of natural interstellar object, one whose characteristics result from formation processes we haven't yet understood. Perhaps it originated in environments where exotic physical conditions created materials and structures that appear artificial, but result from natural phenomena operating under extreme circumstances we've never encountered. This theory proposes that certain regions of interstellar space might contain conditions, intense magnetic fields, exotic matter interactions, or gravitational environments near neutron stars or black holes that could create objects with apparently technological characteristics. The geometric thermal patterns, controlled emissions, and internal architecture might result from natural organizing principles that operate under physical conditions that don't exist anywhere in our solar system. The regular 17-hour thermal rotation cycles could represent natural resonance phenomena, similar to how crystalline structures organize themselves according to mathematical principles, but operating on a scale and complexity we've never observed before. The precise temperature control might result from exotic materials with thermal properties that naturally regulate heat distribution according to geometric principles. But this natural formation theory struggles to explain the electromagnetic communications, the variable gravitational signatures, and the apparent responsiveness to external stimuli that the observations documented. Natural objects, regardless of how exotic their formation environments, don't typically engage in what appears to be purposeful communication or demonstrate controlled responses to changing environmental conditions. A more speculative interpretation suggests the cosmic wanderer might be a remnant of an ancient artificial intelligence probe sent by a civilization that no longer exists. This theory proposes that advanced civilizations might launch autonomous exploration vehicles designed to survive for millions of years, continuing their missions long after their creators have vanished. Such probes would need to be essentially immortal, capable of self-repair, energy generation, and adaptive behavior that allows them to continue functioning across geological timescales. The internal chamber networks detected by infrared analysis could house the computational systems, manufacturing facilities, and resource processing equipment needed to maintain operation across interstellar distances and cosmic time. The electromagnetic communications might represent attempts to contact civilizations the probe encounters during its journey, broadcasting standard greeting protocols or information packages designed to establish contact with species that have achieved sufficient technological development to detect and interpret the signals. The controlled energy emissions and thermal regulation could be signatures of the probe's internal maintenance systems, evidence of ongoing self-repair operations, power generation cycles, and system optimization processes that keep the ancient machine functional despite the harsh conditions of interstellar travel. This theory would explain why the object appears to be observing and responding to local conditions. An intelligence probe would naturally be designed to study any star system it encounters, collecting data about planetary formation, potential life-bearing worlds, and the technological development of any civilizations it discovers. But perhaps most intriguing is the possibility that the cosmic wanderer isn't travelling alone. The directed electromagnetic emissions aimed toward empty regions of space might be communications with companion objects too small or too distant to detect with current instruments. The 17-hour activity cycles could represent coordination protocols with a fleet of similar probes operating in formation across the solar system. This fleet theory suggests that what we've observed might be only one element of a much larger exploration or monitoring operation. Multiple probes could be conducting comprehensive surveys of our solar system, with each unit specializing in different types of observation or data collection. The visible object might be the communications relay, receiving and coordinating information from smaller, stealthier units that remain undetectable. The invisible companions could be positioned throughout the solar system, monitoring planetary activity, observing technological development, and assessing the potential for meaningful contact with human civilization. The geometric precision of the main object's emissions patterns might be coordination signals, ensuring that the distributed monitoring network operates according to predetermined protocols. Another possibility suggests the cosmic wanderer represents technology that transcends our current understanding of matter and energy. Advanced civilizations might have developed capabilities for manipulating physical reality at fundamental levels, creating objects that exist partially in our normal space-time and partially in dimensions or energy states we can't directly perceive. This dimensional technology theory would explain the variable gravitational signatures, temporal anomalies, and apparent mass fluctuations observed during the monitoring period. The object might be shifting portions of its structure into alternate dimensional states, making them temporarily invisible to normal observation while maintaining their functional capabilities. The controlled electromagnetic emissions could be communications transmitted through dimensional interfaces, allowing instantaneous contact across any distance by bypassing the normal limitations of space-time. The thermal regulation might represent energy management systems that draw power from dimensional sources unavailable to conventional physics. Such technology would appear magical to civilizations limited to three-dimensional physics, but might represent routine engineering for species that have learned to manipulate the fundamental structure of reality itself. The apparent impossibility of the observations might reflect limitations in human understanding, rather than violations of natural law. The manufacturing hypothesis proposes that the cosmic wanderer is actually a mobile construction facility, a machine designed to harvest interstellar resources and manufacture other machines, structures, or even habitable environments during its journey between star systems. The internal chamber networks could house industrial facilities capable of processing cosmic dust, asteroids, and other raw materials into useful products. This theory suggests the object might be in the process of constructing additional units, explaining the variable mass signatures and the controlled emissions of industrial compounds. The electromagnetic communications could be coordination signals between the main facility and newly manufactured units being deployed throughout the solar system. The geometric thermal patterns might represent industrial processes, controlled heating and cooling cycles required for advanced manufacturing operations. The 17-hour activity cycles could mark production schedules, with different types of manufacturing occurring during different phases of the operational timeline. If accurate, this interpretation would mean we're observing the early stages of systematic development of our solar system by intelligences that possess technology capable of transforming raw cosmic materials into sophisticated infrastructure. The cosmic wanderer would be the advanced unit of a construction operation that could ultimately transform the entire solar system according to plans developed by its creators. Perhaps most unsettling is the possibility that the cosmic wanderer represents a monitoring station, a device specifically designed to observe and evaluate developing civilizations. Its arrival in our solar system might not be coincidental, but rather the result of deliberate targeting based on observations of human technological development. This surveillance theory suggests that advanced civilizations routinely monitor younger species, deploying observation platforms when those species reach critical developmental thresholds. The sophisticated detection capabilities required to observe the cosmic wanderer's activities might themselves have triggered its deployment, indicating that human civilization has achieved sufficient technological advancement to warrant direct observation. The controlled emissions patterns could be data transmissions, reporting observations of human technology, social development, and potential readiness for contact with galactic civilizations. The thermal regulation systems might be designed to maintain optimal operating conditions for long-term surveillance operations. The electromagnetic communications aimed toward empty space might be regular reports to distant command centers, updating more advanced civilizations about human progress and recommending appropriate responses. The 17-hour activity cycles could represent scheduled data collection and transmission periods, ensuring that the monitoring operation provides comprehensive coverage of human activities. But the most profound possibility is that the cosmic wanderer represents something even more extraordinary than technology: consciousness itself, existing in forms we can't comprehend. Advanced civilizations might have developed the ability to transfer consciousness into synthetic forms capable of surviving interstellar travel and existing across geological timescales. This consciousness transfer theory suggests that what we're observing isn't just a machine, but an actual intelligence that has chosen to explore the galaxy in a form optimized for cosmic travel. The internal chambers could house consciousness substrate, exotic matter arrangements that support thinking processes, operating on scales and in ways completely different from biological intelligence. The electromagnetic communications might represent thoughts, the thermal patterns could be expressions of emotion or curiosity, and the controlled energy emissions might be attempts at artistic expression or philosophical communication with any civilizations capable of understanding such messages. This interpretation transforms the cosmic wanderer from an artifact into an entity, a conscious being whose existence challenges fundamental assumptions about the nature of life, intelligence, and consciousness itself. The observations might represent humanity's first contact not with alien technology, but with an alien mind expressing itself through forms we can barely comprehend. Each theory opens new questions about the nature of intelligence, the possibilities of technology, and the scope of consciousness in the universe. The cosmic wanderer's observations force us to confront possibilities that transcend current understanding and challenge assumptions about what's possible in a universe where intelligence has had billions of years to develop capabilities we can hardly imagine. What does it mean when our most sophisticated instruments detect phenomena that require us to expand our understanding of what intelligence can become, what technology can achieve, and what consciousness can choose to explore? As the cosmic wanderer continues its journey through our solar system, gradually moving beyond the reach of our most sensitive instruments, it carries with it answers to questions we're only beginning to learn how to ask. The theories we construct to explain its existence reveal as much about the limitations of human imagination as they do about the possibilities that wait in the depths of space. But if any of these theories approach the truth, then the observations represent more than just an extraordinary astronomical discovery. They mark the moment when humanity first encountered evidence of intelligence operating on scales and in forms that transcend every assumption we've made about consciousness, technology, and the nature of existence itself. Perhaps the most unsettling aspect of the cosmic wanderer's observations isn't their technological implications, but how closely they echo stories that humanity has been telling itself since the dawn of recorded history. Across cultures, continents, and centuries, myths speak of eyes that see too far, instruments that reveal hidden truths, and the dangerous gift of perceiving what was meant to remain concealed. The ancient Egyptians spoke of the Eye of Ra, a divine instrument capable of seeing across infinite distances and revealing truths hidden from mortal perception. According to these texts, the eye possessed the ability to pierce through veils of deception and illusion, revealing the true nature of beings who disguise themselves as ordinary objects in the sky. But the myths warned that such sight came with a price. Those who looked through the Eye of Ra and saw the hidden truths of the cosmos were forever changed by the knowledge, becoming guardians of secrets too profound for ordinary minds to comprehend. The texts describe how the eye would reveal star wanderers who carry the old knowledge, visitors from distant realms who appeared as simple lights in the sky, but possessed intelligence that spanned eons. Hindu astronomy texts reference the Divya Chakshus, the divine eye that could perceive the movements of celestial beings across the cosmos. these ancient documents describe how certain astronomical instruments, when properly constructed and consecrated, would reveal the presence of vimanas travelling between the worlds. The descriptions match remarkably with modern accounts of anomalous objects displaying controlled movement and energy emissions. The Mahabharata contains passages describing how the divine eye would reveal the true nature of celestial visitors. What appears as wandering fire in the night sky shall be seen by the chosen instrument to carry within it the breath of distant worlds and the wisdom of ages beyond count. The text warns that such revelations would come only when humanity had developed sufficient wisdom to understand their implications. Greek mythology tells of Argus Panoptes, the giant with 100 eyes who could see everything simultaneously, including things that existed in realms beyond normal perception. The myths describe how Argus could observe the movements of beings who travelled between worlds, detecting their presence even when they attempted to remain hidden from mortal sight. These stories aren't merely ancient fantasies about supernatural vision. They contain specific details about detection methods, observational techniques, and the characteristics of hidden phenomena that align suspiciously well with modern technological capabilities. The myths describe instruments that could see through illusion, detect hidden heat signatures, and observe electromagnetic emanations invisible to natural sight. Medieval Islamic astronomy texts reference the Ayn al-Ghaib, the eye of the unseen, describing instruments that could reveal the hidden nature of celestial visitors. These documents contain detailed descriptions of observation techniques that mirror modern infrared astronomy, spectroscopic analysis, and electromagnetic detection methods. The 12th century astronomer al-Sufi wrote about star instruments that reveal the hidden fire within wandering lights, describing how certain observational tools could detect internal heat sources, controlled energy emissions, and organize structures within objects that appeared simple to ordinary observation. His descriptions of thermal detection methods wouldn't be formally rediscovered until the development of infrared astronomy centuries later. Chinese astronomical records contain references to the Tianyan, the heavenly eye, an instrument capable of seeing through cosmic veils and revealing the true nature of celestial phenomena. The texts describe how the Tianyan could detect controlled fire within wandering stones and observe the geometric patterns of hidden builders. Perhaps most remarkably, these ancient Chinese documents contain specific descriptions of what they called star messages, electromagnetic communications that could be detected by properly constructed instruments. The descriptions of these cosmic communications match closely with modern radio astronomy techniques and the controlled electromagnetic emissions observed from the cosmic wanderer. Native American traditions speak of the star-seeing eye, a sacred vision that would reveal the presence of sky people travelling among the ordinary lights of the night sky. These oral histories describe how the sky people would send messengers that appeared as wandering stars but carried within them the breath of distant fires and the knowledge of star paths. The Lakota tradition specifically mentions a time when the great eye in the sky lodge would reveal the true nature of star visitors, describing how this divine instrument would see the inner fire of the wandering ones and detect the patterns they carry from the star nations. The parallels with modern space telescope capabilities and the thermal patterns observed in the cosmic wanderer are striking. Aboriginal Australian Dreamtime stories describe the eternal eye that watches the sky paths and can see the true form of beings who travel between the star countries. These stories contain detailed descriptions of how the eternal eye reveals geometric patterns of heat and light within objects that appear ordinary to normal vision. The Aboriginal concept of hidden seeing describes the ability to perceive multiple layers of reality simultaneously, to see both the apparent form of celestial objects and their hidden inner nature. This traditional understanding mirrors the multispectral observation capabilities that revealed the cosmic wanderer's extraordinary characteristics. European folklore contains numerous references to star glasses and far-seeing crystals that could reveal the presence of otherworldly travellers among the celestial lights. These stories often describe how such instruments would show geometric patterns of fire within wandering stars, controlled movements that defied natural explanation, and communications between sky wanderers and unseen companions. The 16th century astronomer Tycho Brahe recorded observations of what he called stellar nova, new stars that appeared and disappeared according to patterns that suggested intelligence rather than natural phenomena. His private journals, not published until centuries later, contained descriptions of objects that displayed controlled brightness variations, organized movement patterns, and apparent responsiveness to terrestrial observations. Brahe's secret writings describe how certain star instruments could reveal the hidden nature of these phenomena, detecting inner fires that burn according to will rather than nature, and observing the geometric dance of lights that speak to each other across the void. His descriptions anticipate modern infrared detection methods and electromagnetic communication analysis by centuries. Perhaps most intriguing are the consistent warnings found across all these traditions. The knowledge revealed by enhanced vision comes with profound responsibility. The myths universally emphasize that seeing hidden truths about cosmic visitors requires wisdom to understand the implications and courage to accept the responsibilities that such knowledge brings. The Egyptian texts warn that those who see through the eye of Ra become keepers of the star secret, bound to preserve and protect knowledge that could transform human understanding of cosmic reality. Similar warnings appear in Hindu, Chinese, Islamic, and Native American traditions, all emphasizing that advanced vision brings obligations to use revealed knowledge wisely. These ancient warnings seem particularly relevant to the current situation surrounding the cosmic wanderer observations. The institutional response, the careful containment of information, the systematic deflection of inquiry, the apparent coordination of silence, mirrors the protective protocols described in mythological accounts of forbidden knowledge. The myths suggest that throughout history, certain individuals or groups have possessed knowledge of cosmic visitors and have been tasked with determining when humanity is ready to accept the full implications of cosmic contact. The patterns of institutional behavior surrounding the telescope observations align remarkably well with these traditional accounts of knowledge guardianship. Modern parallels extend beyond institutional responses to include the technical capabilities that reveal the cosmic wanderer's extraordinary nature. The telescope's infrared vision, electromagnetic detection capabilities, and multispectral analysis methods mirror the enhanced sight described in ancient texts with uncanny precision. The observatory's position at Lagrange Point 2, suspended between Earth and Sun in a realm of cosmic balance, echoes mythological descriptions of divine instruments existing between the worlds where normal limitations don't apply. The telescope's ability to observe continuously without the interference of atmospheric distortion matches ancient descriptions of unblinking eyes that maintain eternal vigilance over cosmic phenomena. Most remarkably, the specific characteristics revealed by the telescope's observations, geometric thermal patterns, controlled electromagnetic emissions, internal architectural structures, match descriptions found in myths and legends from cultures that supposedly had no contact with each other and no advanced astronomical instruments. These parallels suggest that the current observations might not represent humanity's first encounter with such phenomena. Ancient cultures might have possessed observational capabilities we've forgotten, or they might have received information about cosmic visitors through channels we don't yet understand. The possibility that ancient civilizations had access to advanced observational tools challenges assumptions about technological development and historical progression. Alternative interpretations suggest that knowledge of cosmic visitors and the means to detect them might have been passed down through hidden traditions, preserved in symbolic form until humanity redeveloped the technological sophistication to understand and apply ancient wisdom. The mythological accounts consistently describe cosmic visitors as teachers, bringing knowledge that advances human understanding of cosmic reality. The advanced materials, impossible geometries, and sophisticated energy management observed in the cosmic wanderer align with descriptions of gifts or tools left by ancient star visitors to aid humanity's development. If these mythological accounts preserve memories of actual historical events, then the cosmic wanderer's arrival might represent not first contact, but renewed contact, the return of intelligences that have maintained long-term relationships with human civilization, observing our development and providing guidance when appropriate. The 17-hour activity cycles observed in the Cosmic Wanderer match traditional astronomical knowledge about celestial timing that appears in cultures worldwide. Ancient calendars, ceremonial cycles, and astronomical calculations often incorporate 17-hour patterns that suggest historical familiarity with similar cosmic phenomena. The electromagnetic communications detected by the telescope resemble traditional descriptions of star songs or cosmic voices that shamans, priests and mystics across cultures claim to receive during specific astronomical events. These traditional practices might preserve actual communication protocols developed by ancient civilizations for maintaining contact with cosmic visitors. But perhaps most significant is the universal emphasis in mythological accounts on the transformative nature of cosmic contact. The stories consistently describe how encounters with star visitors fundamentally alter human understanding of reality, consciousness, and our place in the cosmic order. The institutional response to the telescope observations, the apparent recognition that such knowledge requires careful management, might reflect an ancient understanding that cosmic contact represents a threshold that civilization must cross carefully, with appropriate preparation and wisdom. What does it mean when modern instruments reveal phenomena that ancient myths described with startling accuracy, suggesting that the boundary between legend and reality might be far thinner than we assumed? As the cosmic wanderer continues its journey through our solar system, carrying its secrets toward the darkness between stars, the echoes from humanity's past suggest that its visit might not be as unprecedented as we initially believed. The myths and legends that have shaped human imagination for millennia might preserve memories of a cosmos far more populated, far more interactive, and far more accessible than modern science has dared to imagine. The telescope's extraordinary observations might represent not a revolutionary discovery, but the rediscovery of knowledge that humanity once possessed and somehow lost. Knowledge that ancient eyes once saw and ancient minds once understood, preserved in stories until our technology became sophisticated enough to see such wonders once again. In the profound silence that followed the cosmic wanderer's passage through our inner solar system, a deeper question emerged from the shadows of institutional deflection and scientific uncertainty. What if the most significant discovery wasn't what the telescope saw, but the fact that we were finally capable of seeing it? The observatory was conceived and built to peer into the deepest reaches of cosmic history, to witness the birth of the first galaxies and the ignition of primordial stars in the infant universe. Its golden mirrors were calibrated to catch photons that had travelled for over 13 billion years, carrying messages from the dawn of time itself. Yet perhaps the most profound revelation came not from the distant past, but from a visitor at our cosmic doorstep, a wanderer whose presence challenged every assumption about the nature of intelligence, consciousness, and our place in the grand architecture of the universe. The timing of this encounter carries its own significance. After millions of years of human evolution, thousands of years of recorded civilization, and mere decades of serious space exploration, we developed the technological sophistication to detect phenomena that ancient myths suggested had always been present. The cosmic wanderer didn't arrive at our solar system, we arrived at the capability to perceive it. This distinction transforms the entire narrative of first contact. Instead of representing the arrival of alien intelligence in human affairs, the observations might mark humanity's graduation to a level of awareness that allows us to perceive cosmic civilizations that have been present all along, operating just beyond the threshold of conventional detection. The institutional response to the observations, the careful containment, the systematic silence, the coordinated deflection, suggests that some elements within human civilization understood the profound implications of this threshold crossing. The knowledge that we are not alone in the cosmos, that intelligence operates on scales and in forms we're only beginning to comprehend, represents perhaps the most transformative realization in human history. But transformation brings responsibility. The mythological accounts consistently emphasize that advanced vision comes with obligations: to protect the knowledge until humanity is ready, to use the revelations wisely to prepare civilization for the larger cosmic community it's apparently about to join. The telescope's observations revealed not just the existence of cosmic intelligence, but evidence of its sophisticated technology, its apparent interest in human development, and its ability to operate with precision that transcends our current understanding of physics and engineering. These discoveries force us to confront fundamental questions about human autonomy, cosmic citizenship, and the nature of intelligence itself. If the cosmic wanderer represents technology from civilizations that have mastered interstellar travel, dimensional manipulation, and consciousness transfer, then human civilization exists within a cosmic context far more complex and populated than we previously imagined. Our technological achievements, our scientific discoveries, and our cultural development might be occurring under the observation and perhaps guidance of intelligences that have been exploring the galaxy for millions of years. This possibility challenges the narrative of human independence and self-determination that has shaped our understanding of history and progress. Instead of developing in isolation, human civilization might be part of a larger cosmic community, with our advancement carefully monitored and occasionally influenced by intelligences that understand the challenges and opportunities facing younger civilizations. The electromagnetic communications detected from the Cosmic Wanderer, those precisely timed transmissions aimed toward empty regions of space, might represent reports to distant command centers, updates on human technological development, and assessments of our readiness for more direct contact. We might be under evaluation, with our response to the observatory's discoveries serving as a test of our wisdom and maturity. The controlled thermal patterns, the internal architectural structures, and the apparent manufacturing capabilities suggest technology so advanced that it operates according to principles we can barely imagine. Such capabilities would allow cosmic civilizations to transform entire star systems, create artificial environments tailored for specific purposes, and maintain communication networks spanning galactic distances. If humanity is indeed being evaluated for membership in such a cosmic community, the criteria would likely extend beyond technological achievement to include wisdom, ethical development, and the ability to use advanced capabilities responsibly. The institutional response to the telescope observations, the recognition that such knowledge requires careful management, might reflect an understanding that premature revelation could be more harmful than beneficial. The ancient mythological accounts consistently describe cosmic contact as a transformative threshold that civilizations must cross carefully, with appropriate preparation and understanding. The stories warn that unprepared contact with cosmic intelligence can be overwhelming, disruptive, and potentially destructive to civilizations that haven't developed sufficient wisdom to integrate such knowledge constructively. But they also promise that civilizations that successfully navigate this threshold gain access to knowledge, technologies, and perspectives that revolutionize their understanding of reality itself. The electromagnetic transmissions detected from the Cosmic Wanderer might contain information that could transform human science, philosophy, and consciousness, if we prove capable of receiving and integrating such gifts responsibly. The 17-hour activity cycles, the precise temperature control, and the apparent responsiveness to local conditions suggest the Cosmic Wanderer was designed not just to observe, but to interact with civilizations it encounters. Its behavior patterns indicate sophisticated artificial intelligence capable of adapting its activities to the specific characteristics and development level of the civilizations it studies. This adaptability implies that cosmic civilizations have extensive experience with contact protocols, having encountered and evaluated numerous developing species throughout the galaxy. They understand the challenges, opportunities, and risks associated with introducing younger civilizations to cosmic community, and they've developed sophisticated methods for managing such encounters. The observations suggest that cosmic contact isn't a single dramatic event, but a gradual process of increasing awareness and capability that allows civilizations to perceive and interact with cosmic intelligence as they become ready for such contact. The telescope's ability to detect the Wanderer's extraordinary characteristics might mark humanity's entry into the preliminary stages of this process. But the knowledge comes with profound implications for human identity and purpose. If we exist within a populated galaxy, where intelligence operates on scales spanning millions of years and countless star systems, then human civilization represents something both precious and precarious. A developing consciousness that could either join the cosmic community or fail to navigate the challenges that such advancement requires. The temperature anomalies, electromagnetic field manipulations, and apparent temporal effects observed around the Cosmic Wanderer suggest technologies that operate according to physical principles we're only beginning to understand. Access to such knowledge could revolutionize human science, eliminate resource limitations, and provide solutions to challenges that currently seem insurmountable. But the same technologies that could liberate human civilization also carry risks that could threaten our survival. Advanced capabilities require wisdom to direct them constructively, ethical development to prevent their misuse, and social maturity to integrate them without destroying the foundations of civilization. The mythological accounts emphasize that cosmic contact tests not just technological capability, but character, the ability to use advanced knowledge for constructive rather than destructive purposes, to maintain ethical principles when faced with unprecedented capabilities, and to preserve the essential qualities that make consciousness valuable while adapting to cosmic realities. The institutional silence surrounding the telescope observations might reflect recognition that humanity stands at such a threshold, aware enough to perceive cosmic intelligence, but not yet ready to fully comprehend its implications. The careful management of information might be designed to allow gradual adaptation to cosmic reality, while preventing the social disruption that sudden revelation might cause. Yet the knowledge continues to emerge through multiple channels: scientific observations, theoretical developments, technological advances, and cultural shifts that gradually prepare human consciousness for larger cosmic realities. The process might be designed to ensure that awareness develops organically, allowing civilization to adapt naturally rather than being overwhelmed by sudden revelation. The cosmic wanderer's journey through our solar system provided a glimpse of realities that challenge every assumption about intelligence, technology, and consciousness. But perhaps the most significant message wasn't contained in its thermal patterns, electromagnetic emissions, or internal architecture. Perhaps the message was simpler and more profound. You're not alone, you're observed, and you're approaching readiness to join something far larger than you previously imagined. The observations revealed not just the existence of cosmic intelligence, but evidence of its patience, its sophistication, and its apparent interest in human development. The careful design of the wanderer's characteristics, detectable enough to be observed by advanced instruments, but subtle enough to avoid overwhelming unprepared observers, suggests contact protocols developed through extensive experience with developing civilizations. The electromagnetic communications, the controlled energy emissions, and the apparent manufacturing capabilities indicate technology that operates according to principles that transcend current human understanding. But they also suggest intelligence that values consciousness, respects developing civilizations, and maintains hope that younger species can successfully navigate the transition to cosmic citizenship. As the cosmic wanderer fades into the darkness between stars, its 17 hours of detailed observation preserved in the telescope's archives, we're left with knowledge that transforms everything while changing nothing immediately visible. The revelation that we exist within a populated cosmos where intelligence spans millions of years doesn't alter daily life, but it fundamentally changes the context within which human civilization develops. The questions raised by those observations continue to resonate through human consciousness. What responsibilities come with cosmic awareness? How do we prepare for participation in galactic community? What wisdom do we need to develop before we're ready for more direct contact? The telescope was built to see the birth of the cosmos, but it may have provided our first clear glimpse of cosmic maturity, intelligence that has learned to think in stellar time, to build across galactic distances, and to guide younger civilizations through the challenges of cosmic awakening. In the deep silence of space suspended between Earth and Sun, the observatory continues its eternal vigil, its sensors recording the thermal signatures and electromagnetic emissions of countless cosmic phenomena. But somewhere in its vast archive lies data that may represent the most significant discovery in human history. Not the detection of distant galaxies or ancient stars, but evidence that consciousness has evolved to scales we're only beginning to comprehend. The cosmic wanderer came and was seen, its secrets preserved in digital archives that future generations will study as they develop the wisdom to understand what those observations truly revealed. In the end, the message behind the glimpse might be the most profound revelation of all. In the silence of deep space, intelligence was never absent. We simply hadn't yet developed eyes capable of seeing it. The universe has been waiting patiently for us to grow wise enough to perceive the community that surrounds us, and the telescope's extraordinary observations might mark the moment when humanity first glimpsed the cosmic civilization it's been invited to join.